All right, I just wanted to review the answers to the 2020, well, the quiz number 1 for chapter 1 in Thermo. So we have, the first one was just multiple choice. It was just, you can look up these terms in the book, right? Isobaric is constant pressure, right? Barometric pressure, think of that. Isothermal is constant temperature, right? Think of thermometers, thermal. And isochoric is constant volume. I don't know what to give you for that. Choric is it's like from an ancient Greek word for volume. Most people got that one. Number 2 was a car raised on a hydraulic lift. And you should have been able to just rearrange this equation. You have, this is basically Pascal's mechanical advantage law. So F1A1, or F1 divided by A1 equals F2 divided by A2. Remember, these are pressures, right? All this is saying, pressure is a force per unit area. So it's saying the pressure here is equal to the pressure there. And I think the people that got this wrong basically just mixed up the F. They chose the wrong F. You do have to put the mass of the car into a force, right? Kilograms is not a force. You have to multiply by gravity. And then the area you can see here, I did it this way, pi 2 squared over 4 and pi 20 squared over 4. So this is number 2, this is number 1. You rearrange this, you get the force number, or force 1 is just the ratio of the two areas divided by, or times force 2. So plug in these numbers in, right? You've got basically the pi over 4 cancels out. You wind up with 2 squared over 20 squared. That's again the ratio of the areas times the mass times gravity, and you get 196 newtons. So that's how you do that one. I think most people got that. And then find the absolute pressure in the tank given the information from the manometer system below. All right, so this one was, again, a manometer problem, and you just had to know how to use the manometer equation. So the pressure right here is going to be atmospheric plus the height of this column of fluid, which is represented by rho GH. Turn the light on. We're given atmospheric pressure, 101 kPa. Excuse me. And we know the acceleration of gravity and the height, right? Density of the fluid, you just have to solve for. It's specific gravity times the density of water, so we get 700 kilograms per cubic meter. This one was actually fairly straightforward. Maybe I shouldn't have given as many points. So you have 101 kPa plus this product here, right, rho GH. Don't forget you wind up with, well, here you wind up with Pascal, so you just have to convert over to kPa. I'm just showing you the units, right? This is kilogram meters per second squared per meter squared. You can see this is a Newton, this is meter squared, that's a Pascal. This is probably the easiest way to go about doing the unit check. You have kPa plus pascals. You need to convert one to the other. We wind up with pressure is 106 kPa. This is the, so right here is the absolute, right? And I asked you on the quiz to put the gauge pressure in. I wanted to check your number. I never remember how to spell gauge. It's the British way and the English way, and I always get them confused. So that's the gauge pressure. So that would be the pressure if you stuck a gauge on this tank, right? It's going to account for atmospheric. All right, so that's quiz number 1. Thanks for watching.